morning, everyone.
Good morning, sir.
How was your class test one?
Sir, it was a bit lengthy for me, but yeah, it was okay for me, sir.
Which question took most time?
Sir, most probably, I don't remember, but question 4.
Question work for two phase, right?
Yes, sir.
So I asked you guys to practice how many? Two iterations for the first phase, right?
Yes, sir. I have to check the question. Yes, sir.
Two iterations of first one and second one, it will come out to be unbounded solution.
Yes, sir.
You don't have to perform anything.
Yes, sir.
Right. Anyway, I have not yet looked at the. I will actually. I became positive last week, so give me some time. I will grade them as soon as possible. Okay, so let's start with the. Some of you have sent it very late, actually, to my email ID. I will see what I can do, but if it is very late, I might penalize it a little bit because 10 minutes is fine. I actually allowed until 10 minutes, but I have also started 5 minutes earlier. So I don't understand why it took so much time, and excuses like sir mere hall mein power cut ho gaya is not a good excuse for this one. I hope you understand. I mean, little bit late is fine, but that means you kept doing it, and after 10 minutes you started taking photographs and all. So as I said, I will see what I can do while correcting your answer script. I'm not promising anything right now. I will not penalize mostly, but if it is very late in my email box, then I have to penalize it. To be fair with all the students who have submitted it on time. I hope you understand. Okay?
Excuse me, sir.
Yeah.
Sir, I had an issue regarding submission. Actually, I had done the question for in MS Word online. So I couldn't really join the two PDFs, like the one I had written, handwritten, and the.
Why did you do it on MS Teams online? Why don't you do it? I have said pen and paper, na?
Sir, I thought it would
That
have
is the
been
reason
easy.
you might have taken extra time.
No, I didn't take extra time. I submitted it together within time only, but I had to submit two PDFs, one separate for question 4 and the other for the handwritten part. Will that be okay, sir?
Okay, as I said, once I start grading them, I will see. And if anything is required, I will personally contact each one of you and discuss. Okay?
Okay, okay, sir.
Okay. No, I'm talking about people who have submitted it like 25 minutes late. That is, I mean, to be fair with all the students who have submitted on time, I cannot give them so much of, extra time. That's what I was talking about. Okay, so now let's start with the sensitivity analysis. We have looked at your what do you call changes in right hand side. Now we will look at the other two parameters, objective function coefficient C and technology matrix. With B it was much easier. I will again put down the CB B inverse A minus C, CB B inverse A and B inverse. This is your RHS CB B inverse B and B inverse B. Okay. So now we have to split this into which one, if I'm making any changes, whether it is in a basic variable parameter or a non-basic variable parameter, because based on that CB changes and that affects a lot. Also, when I'm changing A, if I'm changing the parameters of a basic variable in the current solution, it affects the B inverse. So we'll treat each one of them separately. So first I will changes in the parameter of non-basic variables. I hope you understood what I'm trying to say. So first one is objective function coefficient. Second one is your technology matrix. So C and A. If you notice, as far as B is concerned, B does not affect your basic or non-basic variable. They are on the right hand side. So whatever B inverse you have, depending on how much you have increased, either you will get a negative number, then you have to re-optimize, or you can be within the range which we have already found. In that case, only the values B inverse B will change. The basic variable will remain same. So let's start with a new example. So suppose I am maximizing G equals to 3x1 plus 5x2. X1 being less than equal to 4, 2x2 being less than equal to 24, and 3x1 plus 2x2 less than equal to 18. So please note, I am proceeding with the last example where I have changed B. Now I will change C. So now suppose for this problem we have already seen after optimization, using what do you call? We have re-optimized this model because we know 24 was outside B value. So the final table which we have got VB equation G x1, x2, x3, x4, x5 RHS. So this is the final table we got for this problem. G x3, x2 and x4 0, 1, 2, 3, 1, 0, 0, 0. Just a second. And x1, x2, x3 are 9 by 2, 0, 0, 0, 5 by 2. RHS is 45. 1, 3 by 2, minus 3, 0, 1, 0, 1, 0, 0, 0, 0, 1, 6, 1 by 2, and minus 1, 4, 9, and 6. So this is the problem for which this is the final iteration we have. Now what we need to do, I'm changing C1 from C1 right now is how much? 3. Let me change it to C1 bar equals to 4. Okay, so what I'm interested, I'm not changing this C1 to 4 or anything. I will try to find the allowable range for C1 to stay optimal. How much I can increase or decrease C1 so that it is optimal. Now tell me whether C1 is a basic variable parameter or non-basic variable parameter. See, I don't have enough energy to, shout your name and anything. So if you want to participate, participate. Otherwise, I will just feel like I'm recording the lectures. So is C1 a basic variable parameter or non-basic variable parameter in the current iteration? I mean the final iteration you have got for this problem.
So non-basic.
Non-basic variable parameter. So again, I have to write it. CB B inverse A minus C. CB B inverse A B inverse CB B inverse B and B inverse B. So tell me, if I make a change in C, where does it affects? Will it affect this part or this part? The only place it is affecting is this one, right? If I want to stay optimal, what I need to make in what I need to ensure? As long as my gth or 0th equation row is greater than equal to 0, I'm optimal or not?
Yes, sir.
So as long as CB inverse A minus C is greater than equal to 0, I can say that I am optimal. Optimal means everything is greater than equal to 0, nothing can enter the basis, so my basis will not change. Does that make sense? So CB B inverse A minus C nu, I am saying, should be greater than equal to 0. So CB B inverse we already have here 0, 0, 5 by 2. This is nothing but CB B inverse. Okay, so I will copy CB B inverse from here 0, 0, 5 by 2. A matrix is our original matrix 1, 0, 0, 2, 3, 2 minus 3 plus delta. Okay, I'm giving a delta how much I can increase C1 or C1 and 5. Solve this one. This should be greater than equal to 0 and tell me what is the value of delta. Solve this as greater than equal to 0 and tell me what would be the value of delta. That is increase or allowable increase or decrease in your C1 value, which is a non-basic variable parameter.
Delta less than 4.5.
Delta less than 4.5. So what you will get here is 7.55 minus 3 plus delta and 5 should be greater than equal to 0 and delta you will get as less than equal to 4.5. So what would be the range of C1 then?
From minus 0.5 to 7.5
How much?
till 7.5.
We generally, because C1 is a profit parameter here, we'll start with 0, right? Even if it is coming minus 1.5, it does not affect, but we'll say that it is between 0 and 7.5. If you increase C1 in this range, your current basis, which is X3, X2 and X4, this current basis remains same. Okay, does that make sense? Any questions, guys?
No, sir.
Okay, so let's look at now technology matrix changes. Technology matrix. A coefficient. And this is for non-basic variable I'm talking about. Basic variable, everything changes. I will discuss very soon. So CB B inverse A minus C, CB B inverse B, CB B inverse B, B inverse B, B inverse B inverse A. Okay, so if I change, suppose A matrix right now is 1, 0, 3, 0, 2, 2. My A new, I'm trying to find the allowable range for A31, let's say. So 1, 0, 0, 2. Let me put it as 3 plus delta. Okay. Or because this is a single value, let me call it, let's see, 3 plus delta A22, I'm calling it. Okay. 3 plus A delta 22. 22 nahi hai. Okay, this is 3, 1. Oh, my bad, sorry. Three plus delta A31 and this remains same as 2. So if I change the A matrix for a non-basic variable, so let me go here. X3, X2, X4 are non-basic variable. So I'm changing for done some mistake. A31 is a basic variable, right? Oh no, x1 है ना 1 3 है. Okay, so I'm changing the coefficient for this one, right? X1, which is a non-basic variable, and X5 is another non-basic variable. Had I changed anything for this, guys, things would be different. But I'm changing it only for a non-basic variable, which is X1 3 plus delta A31. Is this clear, guys?
Yes, sir.
So where this would affect?
In the first column.
Only that this part is being affected when I change A here. Right, because B inverse A part, if you look at it, because of the basic variable structure, it will still remains the same. So I just need to ensure that CB B inverse A minus C is greater than equal to 0. That's all I need to ensure. So let's try to find it. CB B inverse, again we can find directly from the last best known solution 0 0 5 by 2. Your A now is 1 0 0 2. Let me call it A31. I will get that directly the complete range. Minus 4. Again, I am appending on the last question which I have solved. 4 comma 5. Okay. Should be greater than equal to 0. Now give me the range of A31 given this equation. Are you guys able to do it? What is the A31 you are getting, guys? Greater than equal to or less than equal to?
8 by 5.
How much? 8 by 5? If you do this, you will get
Yes, sir.
5 into A31 by 2, comma 5 minus 4, comma 5. Okay, so this will give you 5 by 2. A31 should be greater than equal to 4. Okay, so this is how you will. So are you understanding how change in A in the non-basic variable does not affect anything else? Are you able to visualize it? See, B inverse A is in this part. This is your B inverse. When you multiply this B inverse A, will it change anything in the basic variable, which is in this form right now? You have already seen, because x2 was a basic variable, 5 minus 5 made it 0. You understand? So for basic variable, there won't be any change. It will be of this form only. Some numbers might change here, but as long as I ensure that this number is greater than equal to 0, I'm still optimal. My basic variables are these guys only. Does that make sense? These numbers might change, but these numbers are not really relevant for me right now. All I need to ensure that my basic variables are same. And when I multiply the new A changes in the non-basic variable, it will not affect the column consisting of the basic variable. It will be of same structure 0, 0, 1, 0. If you want, you can try, but you should be able to recognize from here only 5 into 5 made it 0 automatically. Fair enough, guys. Any questions? Just look at it again and let me know if you have any questions. I will take a pause here. Okay, if there are no questions, then now I will move to the another point. What happens when we make the changes in the basic variable? So first look at the objective function coefficient. If I make now changing in the objective function coefficient, what changes I will see? Okay, so if I make changes in the objective function coefficient, right now my basic variable x3, x2 and x4. If I make any changes, how it will affect? Can you tell me? If I make any changes in the objective function coefficient of a basic variable, where it will affect? It will definitely affect your row 0 because the changes which you are making now is affecting CB. You agree?
Yes, sir.
It is affecting your CB, so we have to be careful now. If it is affecting CB and I want to remain optimal with the current basic variables, I want to remain optimal. What all I need to check then? What are the quantities in this matrix form which I have written in terms of CB, A and all that? What I need to check? Which one I need to check?
So CB B inverse A minus C and CB B inverse.
So entire row 0 needs to be checked. If it comes out to be greater than equal to 0, we are fine. Right? So with that, we can find the range of optimality. If it turns out to be, if any of the column, any of the cell in this row 0 becomes negative, then what we need to do? We'll check for CB P inverse A minus C should be greater than equal to 0. First thing we need to check CB B inverse A minus C should be greater than equal to 0 and CB B inverse greater than equal to 0 to find a range to stay optimal. What happens if any of the quantities which you check here, these are nothing but matrix form. So it is 0th row. So x1, x2, x3, x4, x5. Here you have CBB inverse A minus C, and this part you have CBB inverse. Suppose x5 or anything becomes negative, -3. Then what you will do?
That would enter the bases.
Very good. So x5 will enter the basis, and correspondingly whoever is leaving the basis. So you will have a new solution. This is not range to stay optimal, but re-optimization. Keep that in mind. One thing is finding the range to stay optimal. Another thing is, excuse me, another thing is, if I'm encountered with a new kind of solution, I should find my new basis. So let me just check for this one. Suppose let's go back to our original problem. C equals to, this was my C, and I want to make changes in your x2. Okay, so C new is 3 and 5 plus delta. Since x2 is a basic variable right now, we are making changes in the coefficient of x2. So we'll proceed with this one. So we need CB changing. I cannot copy directly from here in the last table. I have to put all of them together. So CB is 0, 5 plus delta, 5 plus delta and 0. Okay. B inverse A, you can directly get it from your the table which you have. So 1 0 0 2 3 2 minus 3 5 plus delta. This should be greater than or equal to 0. Second term which we need to check is CB B inverse is greater than or equal to 0. So 0 5 plus delta 0. No, I have made a mistake here. Let me write them individually so they have no confusion. CB new B inverse, that we need to check first. So this I can raise as CB new is 0 5 plus delta 0 and B inverse is 1 0 0. You can directly copy from your last known solution. Should be greater than or equal to 0. And second thing is CB new B inverse A minus C 0 0 5 by 2 plus delta into A. This I have taken from directly from the table. So 1 0, not table because I will calculate from here. So this will come out to be 0 0 5 by 2 plus delta. This should be greater than or equal to 0, and this CB new B inverse I am using here into A 0 2 3 2 minus 3 5 plus delta. Okay, should be greater than or equal to 0. Solve these two and tell me what is the range in which C2 can lie. You understood? First I have calculated CV new B inverse and I use these numbers to directly plug in here, that into your A matrix minus 3 5 plus delta for CV B inverse A minus C. Solve these two set of equations and tell me what should be the range of delta. Okay, from here, what you will get the delta as? From the first equation, first in equation. So multiplication of these two is 0, 0, 5 by 2 plus delta greater than or equal to 0. So what is delta? Should be?
So greater than -5.
Right? Similarly, if you multiply the, I'm sorry?
So -5,
Yeah.
-5.
Yeah, -5, right? 5 plus delta the whole by 2.
Is it coming 5 plus delta or 5 by 2 plus delta?
5 by
5 plus delta.
5 plus delta.
5. Let me see. 5 plus delta will be multiplying with here. Okay, I will check for timing. Let's assume it is 5. So delta is greater than or equal to -5. Now, when you solve this one, how much you are getting? When you multiply these matrices and then subtract from this matrix, how much you are getting?
Delta greater than equal to 0.
I'm sorry?
Delta greater than equal to 0.
9. Something is wrong. This should have been 5 by 2. Then only you will get here. Let me see if I have copied 1, 0, 0, 0, 0, 1 by 2, 0, 1 minus 1. Where is our table? 1, 0, 0, 0, 0. Something. X4 is here. X2. X3 I am calculating. X4 is coming from here. 1, 0, 0, 0, 0, 1 by 2, 0, 1 minus 1. So this multiplication is 0, 0, 0. 5 plus delta 0, 0, 0. This row into this column, this row into this column. 5 by 2 plus delta by 2, right? So this should have been 5 plus delta by 2. My bad. Can you check how much you are getting now? Because it is over, it is below the 2 also. That was the mistake. How much you get now? Give me the, after subtraction and everything, how much you are getting in the matrix, the row vector.
Greater than equal to -3.
What are the numbers you are getting here? 9 by 2 plus 3 delta by 2 and 0. From here you will get delta should be greater than or equal to -3. Is this correct, guys?
Yes, sir.
So if delta is greater than or equal to -3 and my C2 was how much? 5. So what would be the range of C2?
0 to 2.
0 to 2. On the right hand side we have nothing, right? So C2 can be increased up to infinity. You agree? On the left hand side we have a lower limit on delta. So it should be 2 to infinity. Is this correct? You have to do for C2, you have to do 5 minus delta, na? Or 5 plus delta, whatever delta value could be. So we do not have any upper limit on C2. You can increase C2 as much you want. You will remain optimal. There's a lower limit. Below that, it will be not be same. Does that make sense?
Yes, sir.
Okay. Now, next change. I don't know which number it is. Change in the technology matrix A coefficient for basic variable. Let me write it again. CB B inverse A minus C, CB B inverse A, B inverse CB, B inverse B, and B inverse B. So now, right now we know X3, X2, and X4 my basic variables. X3, X2. If I change technology coefficient for X2, earlier we were just changing it when we are looking at non-basic variable, we are changing it for X1. If I change it for X2, what will happen? So far, we were looking at the RHS, we were looking at this part, and we are looking at the other non-basic variables, coefficient and other basic variable of objective. We are only concentrating on this one. If I change coefficient of B, will it infect my B inverse? How do we get B? From A comma I matrix for basic variables, right? If I change the coefficient of a basic variable in A matrix, what will happen? Will it change my B inverse? You guys remember how do we get the B matrix? Or you have already forgotten? Exams are over. How do we get B matrix? Anyone?
So from AI matrix, we eliminate the column corresponding to the NB non-basic variable.
Non-basic variables. So right now it is X3, X2, X4. If I make any changes in the A matrix, it will affect here. If I take B inverse of this matrix, it will also be changed. You agree?
Yes, sir.
So whole thing changes. You remember when we studied revised simplex method, the most important calculation in any iteration is what? B inverse. So generally there are ways to work with the last known solution, but for the scope of the class, this will change B matrix. Thus, set up simplex tables from scratch. That means treat it as a new problem and start from the initializing. Later, maybe once the semester ends towards that, I will tell you how to work with the existing one also. In fact, you can also think of it as whatever last matrix you have to put the new variable, new coefficient, convert into proper Gauss-Jordan form, and you can proceed. But in any case, your solution will be a new solution, whether you do it from the last known solution or start. But for the scope of this class, I'm just telling you, you treat it as a new problem and solve it from scratch. Is this clear? Suppose if I add a new variable, so suppose I have been selling product 1 and 2, correspondingly X1 and X2 are the variables representing it. You ran the production plan for 1 year and you want to introduce a new product. Since I have used X3, X4, X5, so I will call it XP, the new product. If I'm adding a new variable, what should we do from the last known solution? So let's say my columns looks like this: X1, X2, X3, X4, X5. Okay, RHS. Okay, suppose basic variable right now is G, X3, X2, and X4. This is the situation I have right now. Final iteration, which is known to you. Okay, now I will say that I want to add a new product line in my, stuff. What should we do given this table? Should you solve it as a new problem altogether? Or you can proceed from here? Yes, any ideas?
Could we like add it as a non-basic variable?
Very good. So think of it as a XP was always there. Okay, and all the coefficients were 0. Think of it like that. You have started solving this problem. From the beginning itself, XP was there, but all coefficients were there. So whatever you multiply, subtract, add, it will be 0 throughout. Now think of it as it was a non-basic variable. So you change its coefficient from 0 to whatever number it is. Suppose it is 8, and A matrix coefficient 1 by 1 you can change, or you can plug in these numbers directly here. Okay. Once you plug in these numbers, because XP had changed, it will be -8 or something like that. Okay, so it will try to enter the basis. So you will be able to find your new solution. Whether XP is worthwhile to produce or not, you will be able to know from there. So I will write it up for your adding a new variable is equivalent to changing the coefficient objective function and A matrix of a non-basic variable. Let's say initially all the coefficients were 0, and now you change it to a new value. Is this clear, guys? If you have any questions, feel free to ask. The last one is adding a new constraint. So suppose we had 3 constraints earlier. There is some new labor law. Because of that, I need to add a 4th constraint. What would be the effect? Okay, just let me tell me one question. If I add a new constraint, is it going to increase my objective function value? Can adding a new constraint can increase objective function value?
I think no, sir.
It is not possible, right? I mean, just look it from, suppose this is how my problems feasible region looks like. No matter where you add the constraint, it will make the feasible region even smaller, right? So first thing, not adding a new constraint would not improve the objective function value. First thing. But can create infeasibility. Adding a new constraint can make the the current solution infeasible. Is that correct or not?
Yes, sir, it can.
So first thing, suppose right now my solution is 0,9. I added a new constraint. What I will check? Whether the current solution satisfies this equation or not, right? Suppose x1 is less than equal to 4, 2x2 is less than equal to 12, 3x1 plus 2x2 is less than equal to 18. Let's say my current solution is 2,6. I added one more constraint, 5x1 plus 3x2 is greater than equal to 2. Does the current solution satisfies it? It will satisfy these three constraints, but it will violate this constraint. Is this correct? No, it is satisfying. 30, 10, and 18. Let's say 45 I have said. It will violate the constraint. So first thing is, if current solution is feasible for the new constraint. If the current solution, whatever the last solution known to you, is satisfying the new solution, what can you conclude? If the current solution satisfies the new constraint, what can you conclude there? If the current solution is optimal solution, adding a constraint will not change your optimal solution. Do you understand if it is feasible? Does it make sense? Suppose this is how my solution looks like, 2,6. If I add a new constraint like this or whatever way it is being satisfied, it will not change my current solution. Current solution is satisfying. That means I have already taken care of the feasibility. So the current solution is optimal. If not, then start from scratch, because in this case your B inverse matrix will change. Okay, so if you add a new constraint, first check whether it is feasible or not. If it is feasible, then you don't have to do anything. You can conclude that we are at the optimal solution already. If it is not feasible, that means when you plug in the numbers here and it turns out to be infeasible, then you have to start from the scratch. So this is where we end the simplex algorithm. Next class, we'll start with transportation and assignment problem, the next topic in this. Luckily, no more simplex. I mean, there will be transportation simplex, but it does not look like this. So transportation and assignment problem will start on Friday. Also note that next Friday, that means the week of, where is my calendar? Yeah. 11th March, I have scheduled a guest lecture from an industry expert. He holds many patent in optimization and supply chain management from Blue Yonder. So he will be delivering an hour lecture. So I request all of you to please join. This will give you an insight how optimization is used in the real world. Okay, so 11th March, please note down the date. I will also send an reminder to you guys. It is an industry speaker. He will take 1 hour lecture and tell you how these optimization techniques which you are learning here, he's using in day-to-day life to solve the industry problems. Okay. So any questions? So Friday I will start transportation and assignment problem, and then after we complete transportation and assignment problem, I will teach you Markov chains and queuing theory. Thank you very much, guys. If you have any questions, please ask regarding grading your midterm. Midterm, I won't say midterm. Class test 1. Give me some time. By next week, I will be able to finish it. Thank you.
Thank you, sir.
Thank you, guys. Bye bye.
Thank you, sir. Thank you, sir.